metamorphic methodology from chemical equilibrium. So during our metamorphism, mostly they are associated with chemical reaction. So with increasing temperature pressure, rock will convert to metamorphic rock by some reaction, or during increase of grade, phases or zone, all are associated with reaction. So first we'll see what is chemical equilibrium in a reaction. So when we'll say reaction will attain chemical equilibrium, so when the rate of forward reaction is equal to rate of reverse reaction. Suppose we take two substances. Suppose we take two substances X and Y. Then we mix them. Like you can say कि you are taking phosphate and silica. If you mix them, they will react to form another substances. So when we take two substances X, Y, then at suitable temperature and pressure, they will react with each other to produce other substances. Suppose we'll take X plus Y, they are producing C plus D. This thing is called as chemical reaction, where X, Y at suitable temperature pressure, they rearrange themselves to another form, that is C and D. So this rearrangement of atoms from one configuration to another is called as chemical reaction. So atom and rearrangement, so when they will mix with each other, they will rearrange with themselves to form another substances. The reaction will continue until this reactant X, Y are available. One of them will consume, the reaction will stop. So that it is possible that all the X5 can convert to C plus D, or all the X5 convert to C and D. Very good. That will be a complete conversion of XY into CB. So if the reaction is not reversible, if the reaction is not reversible or irreversible, then all XY, there will be XY also, all X and Y will convert to C and D. All the X and Y, they will convert to C and D. So in this case, only there is a forward reaction. There is no reverse reaction. So that means if one directional reaction cannot achieve equilibrium. Equilibrium achieve kariପାରିବ ନାହିଁ. So if I am saying here there is a only reaction from a reactant to product side, that means it is a irreversible reaction. The reaction will complete, but they will never achieve equilibrium condition. So irreversible reaction, they cannot achieve chemical equilibrium. They cannot achieve the reaction will continue, reaction will complete. The irreversible reaction will complete. But if it is a reversible reaction, the reaction is always incomplete. Reaction का incomplete. The amount of XY in the expense of XY CD will form, and in the expense of CD again XY will form. So in that case, there is a condition where the rate at which XY is converting to CD will be equal to the rate at which CD is converting XY. So the reaction will always remain incomplete, but they will achieve a equilibrium state. So when in reversible reaction, the reversible reaction achi then our x plus y is equal to c plus d. The rate of forward reaction rate of forward reaction is equal to rate of reverse reaction. Then we can say they are attaining chemical equilibrium. We can calculate the rate of forward reaction by this. The R forward is equal to K forward into concentration of X into Y, and reverse equal to K reverse concentration of C into D, where you can say X, Y, C and D. They represent concentration, K reverse K forward. These are proportionality constant. So you can say a rate constant. So during chemical equilibrium, R forward equal to R reverse. So now we will equate these two equations. R F लिख दीजिए, F for forward है ना, equal to K forward, sorry, R forward equal to R reverse, chemical equilibrium. Because during the forward reaction, in expense of xy, the xy will decrease with increase in CD, and in reverse, CD will decrease with expense of xy will form. So that is the condition where both the rate will same, so the concentration will remain equal. So you can say K forward xy, because R forward equal to K forward xy is equal to K reverse C T. So we can write this like this: K forward by K reverse will be concentration of the reactant by concentration of product. So K forward by K reverse, it can be written as only K. K forward, oh, sorry, उल्टा हुआ ना, K forward by K reverse, K forward by K reverse उल्टा डाल. Hmm. Thanks. Hela. So during the one chemical equilibrium, concentration of product by reactant আছে କାରଣ concentration of product by reactant তুমি ତାକୁ ବି K କହିପାରିବ ଗୋଟେ constant, because କି କ'ଣ K forward R forward ଦିଟା, K forward ଆଉ K reverse ଦିଟା constant, ତାଙ୍କ division ବି କ'ଣ ଆସିବ, constant ଆସିବ. So this is can also called as law of mass action. The concentration of product by concentration of reactant which is constant, that is which is law of mass action. So these concentrations, they can be represented on the basis of activity. Okay. So the requirement only you remember about the concentration. So if you represent this or forward and R reverse in a graph, so this is a graph where you can represent R forward and reverse reaction, where this is the time, this is the rate of reaction. So R forward will always decrease and R reverse will increase gradually. Then the rate will meet at one point where they will attain chemical equilibrium. So here at this line, you can say reaction attains equilibrium. And on this line, you can say R forward equal to R reverse. Lee Chattel principle कौन होती है? यदि कोटे reaction, if a reaction is at chemical equilibrium, so if anything changes like temperature, pressure, then the equilibrium will break. So it will be in equilibrium condition. So then The reaction again will start. Either R forward will be greater or R reverse will be greater, and then again spontaneously they will achieve equilibrium. So during tomorrow, the chemical reaction at equilibrium, and if it experiences change in the pressure, temperature, or concentration of products or reactants, anything, the equilibrium shifts in the opposite direction to offset the change. Suppose the product has more concentration, then it will move towards reactant. The reactant has more concentration. If you are adding more concentration, suppose the example of xy equal to CD, they are in equilibrium condition. Now, if you add more xy, then it will convert to CD. It will move in that direction. If you add more CD to the product, then it will react in a reverse way to produce xy to maintain the chemical equilibrium. That is your Lee-Jattanier's principle. So we will take an example like H2O plus CO2, that is H2CO3. The atmospheric carbon dioxide when mixed with water it will produce H2CO3 carbonic acid, bicarbonate. So if the equilibrium is disturbed, for example, that is small increase in partial pressure of carbon dioxide. So the reaction will proceed in the forward direction because the partial pressure is increasing in the product side, the reactant side, so it will move towards the product. If similarly there is a small decrease in PCO2, that means ki if partial pressure will decrease here, then reaction move from product to reactant to establish the equilibrium. Understood? So any change in here we are taking pressure, you can take concentration, you can take temperature. Any change in that thing, the equilibrium will shift. So that's why by either it will the reaction will be a forward reaction or it is a reverse reaction depending upon in whether you are applying pressure or temperature to a reactant side or product side. If you apply temperature pressure in the reactant side, it will move to the product. If you are applying pressure in the product side, it will move towards the reactant. So this principle can be applied on mineralogy or petrology case. If there is an increase in temperature, it should favor reaction like melting. So during melting, heat will absorb or temperature will increase. So it will be endothermic reaction. Whereas decrease in temperature, it will crystallize melt solid melt will become solid. The temperature will be a reverse process where it will be an exothermic reaction. That means during melting, the temperature is absorbed. So that means it is endothermic, and during reaction from the crystallization from the melt, it will be an exothermic reaction. So that's why they are maintaining equilibrium by absorbing heat or by releasing heat. So from melt to solid, from solid to melt. Then there is also changes in volume. तो volume भी change हुए because की so suppose की this thing jadite it is reacting with orthoclase albite. Jadite. This is albite. Analchem. Albite analchem they are producing jadite. Here the molar volume is 2.3. Here molar volume is 1.2. So there is a net decrease in molar volume here. So there is a significant reduction of volume led to combined volume of the reactants. जो कि नॉर्मल तुम्हें सॉलिड नेट ट्रांसफर रिएक्शन है देखिए केस तुम्हारा मेटामॉर्फिक केमिकल रिएक्शन है solid net transfer reaction like this. So this is not analkane, this is nepheline. Uh, So albite plus nepheline is jadite. Jadite obviously NaLSI2O6. It is a alkali pyroxene. This is albite. This is nepheline. So albite react with nepheline, producing jadite. देखा? So a thermodynamic system, it is some part of universe. System, you can say it is some part of we choose to study for addressing a given problem. The rest universe beyond the chosen system is called as surrounding. We were choosing a system. After that, the rest of the universe will be surrounding. So this is a system, and rest of the world is rest of the universe is surrounding. So any system can be isolated, can be closed, can be open. So three types. Isolated, there will be no exchange in mass or no exchange in energy. It's completely isolated from the surrounding. That it does not interact with the surrounding. But in a closed system, there will be no mass exchange, but there will be energy exchange. Like it can absorb heat, it release heat like that. In open system, mass and energy both will change. So there are three types of system. These are different kinds of process for change of state. जोटा कि isothermal कौन सी जोटा constant temperature, isobaric for constant pressure, isochoric for constant volume, and adiabatic for constant heat content. So during your isothermal system, there will be no change in temperature. So change in temperature will be zero. For isobaric condition, change in temperature, that is dP will be zero. And for isochoric, dP equal to zero, there will be no change in volume. And for adiabatic, dQ equal to zero. The divergent plane boundary is so adiabatic process where there is a constant heat, it will not change. So adiabatically that was rising. And more of the phase components and phase rule that will cover in Gibbs phase rule. Then comes to this thing, that is state of the system. Or you can say there are variables. So there are two types of variable we define. One is your intensive variable another extensive variable. So extensive variable, it depends upon the quantity of material. Quantity of the material in the system. So it can be your mass, volume. We can say example. You can take mass, volume, number of components, number of moles, etc. So extensive means it defined through the quantity, defined through the quantity. So that's why uh, these variables are not intrinsic property, because if you change the volume or mass, the substance will not change, phase will not change. Suppose you have 10 gram of water, if you add more 20 gram, it will still remain water. Only the mass will change or volume will change. If another 20 gram, same. But if you change the temperature or pressure, there will be a change of state can happen. So they can affect the intrinsic property of the substance in the system. In case of the intensive variable, so what is intensive variable? They do not depend upon the size of the system. They do not depend upon size of the system. Or you can say properties of substance. The example of the example will be pressure, temperature, and densities. So with change in pressure, temperature, there will be change in state. So there will be change in intrinsic property or the change in molecular property. Always remember, if you divide two extensive property, it will produce an intensive property. If we divide any extensive property by another one, it will be an intensive property. Like example, you can say density, mass by volume. Mass is called extensive property. Volume is extensive property. So mass by volume is density. We have first law of thermodynamics. So it states that the change in the internal energy of a system del U, internal energy U. So change in internal energy of a system between two states. So the changing states, the system is changing states. So the change in internal energy, when it will change state, it will be equal to heat absorbed by the system equal to heat flowing into the system যেতে তোমার হিট ফ্লো হচ্ছে সিস্টেম কো and work done. So this can be represented mathematically by del U is equal to Q plus W. So U is an internal energy, Q work. So differential form will be like this. U, you take the derivative for very small change in internal energy, then you can write down very small change in heat and work done. So dq dw, there are very small change in heat and work done, and that's why there will be very small change in internal energy. बहुत कम चेंज में हमको डिफरेंशिएशन dw. So dw it can be written as fds. Huh. dw equal to fdx. You can write down work done equal to force into displacement. Suppose we have a cylinder in pressurized condition. We are pressurizing the cylinder like this. Okay. In this case, cylinder is experiencing some work done. That is, you see dw equal to fdx. If you release the pressure, if you release the pressure, then it will expand in the upper direction. So it will consider negative force. It will consider negative force. So the force you are applying to the cylinder, it is positive. The cylinder is applying the force that is negative. So that's why dw equal to minus fdx. Because कि तुम्हारा एटी हमारा एक्चुअली क्या है dw is equal to f dx cos theta. Huh? When we are applying force, that cos theta equal to 0. So that's why f dx. If it is in opposite direction, the force and the movement, force and displacement, they are in opposite direction. So that's why in that case, cos will be 180. So cos 180 will be minus 1. So that's why dw equal to minus f dx. So it can be written as if we take dw equal to, we will multiply a and divide a. F a dx by a. A is which kind? Area. A is area. So the equation will become dw equal to F by A, force by area. It will be pressure. This is area and this is another length. So area plus area into length now. Volume. So it is dx. So that's why the volume will be dv. So dw can be written as minus pdv. So if you substitute this in our the first law thermodynamics equation, that is d equal to dq plus dw. So in place of dw, we will replace minus pdv. So the first law will become du equal to dq minus pdv. So and the FOG force A is area, dx is small change in length or a small change in can say displacement. Then dw is a work done. So in fast law, there is only it is saying the change in energy during some the work done and heat will be observed. But it is not saying in what direction the reaction will proceed, whether it is a reverse reaction, forward reaction, how they are achieving equilibrium. So that thing is represented in the second law. So, but the second law states, so there is a natural direction in which the reaction will tend to proceed. So there is a natural direction in which reaction will tend to proceed. So this direction is inevitably is a higher entropy of the system, and that means the reaction will always proceed towards the higher entropy direction. So that जो direction is more अधिक higher entropy can it can achieve. So in that direction it will proceed. केमती बुझिबा एटा? Let's take an example. See, so we'll take two cylinder. A, another is your B cylinder. We'll connect them. So it is filled with gas. It is filled with gas. So it is filled with gas. Now suppose we block the flow with a cork here. So we have taken two cylinder A and B. So they are well insulated cylinder. Like that filled with gas. So it is connected to another cylinder, that is B, which is the connected pipe. It is have a stop cork. So if you remove this stop cork, then what will happen? Hmm? Gas will flow like this. That will fill the second cylinder. So now this gas from the A cylinder, it will expand to the B cylinder, and it will flow until they will achieve the equilibrium. But here what happens is, without any application of force, spontaneously the gas are moving from cylinder A to cylinder B, and doing that they are increasing their entropy. This is their entropy, because the more the space, the more the entropy. So now the gas was confined to this cylinder only up to this much volume. When it spreads, it expands. So now it is distributed in a greater volume area. So now the amount of gas that is distributed within this cylinder only, now it is distributed in two cylinder. So the volume will increase, so the entropy will increase. That's why the reaction always proceed towards a higher entropy condition. Higher entropy condition. So, but the reverse case is not possible. Reverse case is not possible. You have to apply some force to move the gas from B to A again. So this spontaneous thing, it is because of entropy. Because any change in energy in system, that should accompany it with the absorption of heat or work done. That is on the basis of first law. But on the basis of second law, it can be occur by naturally, without application of force. So like always the reaction proceed towards higher entropy condition. So entropy increase करिए because volume will increase, volume increase करेगा so entropy increase करेगा. So here you have to see entropy. So entropy कौन? Is the कौन? Degree of randomness or disorderness. So entropy can mathematically represented D is equal to dq by T. So dq तुम्हारा like a small amount of heat, खाली heat लिखते हैं, dq तुम्हें जाएगा heat absorb और T होची temperature in Kelvin. When ds तुम्हारा ds equal to dq by T, in that case it is करा जो reversible process. It is करा जो reversible process. This is very difficult actually. So spontaneously there will be no reversible condition. You have to apply some force. Force applied for reversible condition, where heat absorbed by temperature it will be equal to entropy. But if it is greater than if the entropy is greater than the heat absorbed by temperature, there is a irreversible process. If ds is greater than dq by T, it is an irreversible process. Where you cannot exactly calculate the ds. Where ds will exactly calculate the value one. So it is always greater than the value of dq by T. So we can write down that. So the complete expression can be written as ds greater than equal to dq by T. That is your second law. Understood? So that's why we consider entropy. The entropy will increase also in change of state. So always our entropy of solid state will be less than liquid than gas. That means the entropy of gas will be highest. The particular material it is existing in three states. The gas state has more entropy or highest entropy than other state. You can say entropy of gas is greater than entropy of liquid is greater than entropy of solid of a substance. Then the equation that combines the first law and second law. So first law thila kon du equal to dq minus pdv. The first law of equation. So in place of dq, we can replace the ds equal to dq by t. So in case of dq, we can write down dq equal to tds. So the equation will become du equal to tds minus tds minus pdv. This is your third law. So third law indicate कि entropy will be zero at absolute zero temperature. Entropy will be zero at absolute zero temperature. So entropy of any at if you change the temperature, then the entropy will change. So for at absolute zero temperature, entropy will be zero. The example you can write down a perfectly crystalline substance. Well, a perfectly ordered arrangement crystal where the ions are fall to their correct lattice position and they will not move. They will not vibrate. So when temperature will increase, they will vibrate. They will show randomness. They will show disorderness. So if at 0 degree temperature, they will be at their lattice position. So only tanko lattice position thibe and some change heavy unless until you are applying some temperature or other thing. Like that will increase the molecular vibration. Or it also associated with state of change of state, so that will increase the entropy, but at absolute zero temperature entropy will be zero. That is the third law. So enthalpy is the auxiliary thermodynamic function that indicate the heat content within a rock or within a substance. This is the heat content in a system at constant pressure. So actually we cannot measure the heat content. We can only measure the change in heat or change in enthalpy. For a particular system, तो enthalpy measure कर पाएगा. हमको I have to measure the change in enthalpy. कहते हैं enthalpy change होता है. So dH change in enthalpy it can be calculated by this equation. Change in internal energy plus work done plus volume into pressure, change in pressure. So du it can be written as dq plus minus pdv from first law. So dv can be written as dq minus pdv plus pdv plus pdv. This will cancel each other. So dh will become dq plus but at constant pressure dp will be 0. So at constant dP will be 0. So the equation will become pH at constant pressure equal to dQ constant pressure. So that means at constant pressure, enthalpy is equal to heat content. So during the reaction, whether reversible or irreversible reactions or any change in enthalpy at constant pressure can be measured by the any change in heat absorbed or heat released to the system. The dH equal to dQ. Then comes to gives free energy. So it indicates the amount of energy available for the system to do useful work at constant pressure and temperature. So it can be written as mathematically G equal to H minus Ts. Enthalpy equal to temperature into entropy. So for very small change, it will be Bg equal to Dh minus Ts. Dts. So Dh can be written as enthalpy equation Dh dq plus vdp vdp minus vds. So dq can written as du vdp plus vdp. Hmm? রড ছাড়লে equal to h minus ts. So t is equal to dh minus देखो अब tds tds होगा ना sdt होगा. Hmm? अच्छा तो dq dh बदल लिख लेंगे तब q plus vdp. du can be written as TDS minus PdV TDS minus PdV plus PdV plus PdV minus TDS. तो PdV PdV कटिगला TDS TDS कटिगला अब रोइला तो नहीं so dg equal to VdP minus SdT. dg equal to VdP minus SdT. एवढा बार G equal to H minus Ts, so G equal to U plus PV minus Ts. So we'll take the derivative. So dg equal to du plus d plus PV, then minus d plus d into Ts. So if you take the if you apply the product rule, so that du plus d PV plus d Vp. See PdP. देखिए दोस्त देखिए P dV plus V dP है minus S dt minus plus TTS. See derivative. du plus PdV कौन आवा du ର value होची TDS minus PdV ସେଥିରେ ଗଲା ଗଲା TDS PdV ଏଟା କଟି ଯିବ ନା नहीं तो बढ़िया कौन dg equal to VdP minus S so this is the equation. So at constant pressure dg is equal to minus S dt, or you can say dg by dt at constant pressure will be equal to minus S. Then at constant temperature dg will become VdP. That means dg by dP at constant pressure, constant temperature will be equal to volume. The both at constant temperature and pressure, then change in the energy will be 0. So that's why G decreases with increasing temperature at constant pressure. from the G value, you can determine whether the system is in equilibrium condition or stable condition or unstable condition. So from a reaction, we can calculate the del G value of the system or the reaction, that is product and product minus reactant. Calculation of del G of a reaction. So that is a reaction. We take A plus 2B equal to C plus 2D. So free energy of C del G is regular. C del G plus 2 into D del G minus the del G नकर खाली G del G will change in energy time बाहर कर सकते हैं. The change in energy will be reactant minus the summation of energy in the reactant product minus in the reactant. So in this case, if the value of del G is 0, then del G if that value is 0, if del G is 0, that means it is in equilibrium condition. The reaction is in equilibrium condition. Del G यदि less than 1 आला, the reaction should spontaneously proceed towards the energy का रहता है. यदि del G less than 0 होगा, तो energy will be more in del G less than 0. क्या रहता है? So during del G less than 0, the reaction should exist. The reaction should proceed. Spontaneously to the direction of product. The reaction will proceed towards the product. Lower energy, so that's why product minus reactant minus so lower energy third को shift out. So if del G greater than 0, the reaction proceed towards the reactant essence. at constant pressure temperature condition. PT लिखियो del G if it is greater than 0.